Hello everyone. In today's tutorial, we are going to be considering a question under isotope. A question under what? Isotope. And the question says, oxygen is a mixture of two isotopes. This is the first isotope, oxygen with proton number 8, mass number 16, and another isotope of oxygen with proton number 8 and atomic mass of what? 18. Okay, with percentage abundance 90% and 10% respectively. So what's the question? Calculate the relative atomic mass of oxygen. All right, so we are asked to calculate the relative atomic mass of these isotopes of what? Of oxygen. Of course, what is relative atomic mass? The relative of atomic mass of an atom of an element is defined as what? As the average mass of the what? Of the atoms when it is being compared to 1/12 of that of what? Of the mass of carbon 12. Alright, so but we are not asked to define relative atomic mass. However, to calculate relative atomic mass, there is a general formula that you can use to calculate the relative atomic mass of isotopes of an what? Of an element. Are you getting me now? Alright, so what is the formula? I will write the formula for you. Relative atomic mass, RAM, is defined as, now by formula rather, percentage 1 times M1 divided by 100 added to percentage 2 times M2 divided by what? 100. You see, this formula will solve any problem under relative atomic mass that have to do with what? Isotopes. And if you look at the board, we have just two isotopes. That's this represents the isotope, the first isotope, and this represents the what? The second isotope. Now, what is the meaning of this percentage 1? This percentage 1 simply means the percentage abundance of the first isotope. It must be given in the question. However, it might not be given in the question, but there's a way we can calculate it. All right. So if you look at the question, we said with percentage abundance of 90%. So it means that for the first isotope, the percentage abundance is what? 90%, right? Okay. Then what about the second isotope? What is its own percentage abundance? That's what? 10%. Please listen. It will be given in the question. All right. Now we move on to the next thing, which is what? M1. M1 means the atomic mass of the first isotope. All right. So when you have an atom, right? Let's say you have an atom. Let me write it here. If we have an atom X, this is an atom of an element, unknown element. Now, whatever number that is written here is usually called the what? The proton number. It's called the what? Proton number. Of course, an atom is made up of 3 subatomic what? Particles, which are the what? Proton, the electron, and the what? Neutron, right? So this any number written down here is called the proton number, which we all usually call the what? Atomic number. The what? Atomic number. But under relative atomic mass, isotope, we don't make use of the what? The proton number. Rather, we make use of the what? The atomic mass. So how do you get the atomic mass of the atom? Just go to the isotope, the atom. Any number written up here is the what? Is the atomic mass. All right. So that's what I mean. All right. So let's go back to the question. So for the first isotope, what is the number written here? 16. So 16 is the atomic mass of the first isotope. That means 18 will be the what? Atomic mass of the what? Second isotope. So once you have written this parameter out, we will substitute it in the formula. Now let's substitute it in the formula. The relative atomic mass of this isotope is equal to what? Now what is percentage abundance of the first isotope? 90 multiplied by the mass number of the first isotope is what? 16. You will divide it by what? 100. This is the formula. Just know this formula. You add it to what is the percentage abundance of the second isotope? 10 multiplied by what is the mass number? 18. All right. You divide it by what? By 100. Right. So using your calculator, let's use calculator and multiply. 90 times 16 divided by 100 is equals to, that's 14 point what? 14.4, right? Then also, uh, let me check it again. 90 times 16 divided by 100. Yes, it's correct. 14.4. Then this is 10 times 18 divided by 100. This is what? 1.8. So what you do next is you will add the two together. Plus 14.4 is equals to 16.2. So it means that the relative atomic mass of these two isotopes combined, the atom of this oxygen that has these two isotopes is what? 16.2. Now, permit me to tell you that no matter the answer you get here, it must be within the range of 16 and what? 18. If you get any answer below 16, you are wrong. If you get any answer above 18, it means that because you are calculating relative atomic mass, and the relative atomic mass of an element is the average mass. So we are finding the average mass here. Do you understand? So your answer should be in the range of 16 and 18. Do well to share this video. Thank you. Bye.